I've been having a rant with my students, and I tend to tell them, I want you to write dumb code. Don't write smart code that use every features of C++ you can think of, or whichever language you happen to be using. I want you to write code that is readable. And they have a hard time getting there. They're sort of saying, oh, yes, but, I'm using Scala and implicits, and you don't have to write almost nothing. It all gets filled in by the compiler. And then you're in Rust, and I have this macro system, and, it'll expand this one line into 50. It's wonderful. Then you get to the point where you want to debug, teach it to newcomers, and the code is completely unintelligible. And it's an interesting thing. Like, of course, macros, of course, all these features have their benefits, but there is this slippery slope where understandability starts to sort of evade, because you're looking at code, but there's not enough syntactic hints for what it will do. And
fully agree. I fully agree. I even think I wrote a paper about implicit type definitions that goes in the spirit. Implicit type definitions are great because compilers can deduce what the type is. But what about the reader? Should the reader be so smart as to be able to reproduce the inference capabilities of a compiler to guess what the type is? When we write something, it's not just for executability, it's for the reader. It's for, even if the reader is yourself. I fully agree.
There's a really, sort of interesting debate where, how much should be in the text, and how, I don't know that I have the answer, but I am sure that I've seen way too much code that, that is completely, that takes so much time to understand, that whatever benefits the authors gain by having, avoiding boilerplate and, not writing, definitions, declarations, is completely obviated by, that the costs that come later on for the people who have to deal with their code.
When preparing this conversation, there was one question I want to push to you, because I have an opinion, but I really wanted to pick your brains first. There has been that post on LinkedIn where they make a kind of a point of saying, C being 1, Python is 5 times the power consumption, Java is 3, Rust is 7. I don't remember what the figures were. And that on LinkedIn, there are quite a few environmental people making claims on, and not that I'm disputing that as a matter of principle, but they were saying, okay, do you see, we should use languages that are less power hungry because, it's not environmental friendly. What is your take before I start me ranting on mine?
So I think there's 2 things that I want to say about power. One is, we as computer scientists are not trained to think about power. Our normal reaction is, if I add one more core and get a 10% speed up, it's a win. And you say, well, but you're using way much more power. That can't be a win, but it is. So it is because our our metrics, our performance, and we never think about that. So in one sense, I think as a computer scientist, we've just never thought about it, or most of us haven't. Now, so that's one thing I wanted to say. The other is that, comparing the power consumptions of programming languages on trivial problems is silly. What you want to do is compare them on real systems. And so if you think of Python, most of the real system work is done in C anyway. And the costs then are in the algorithm most likely. And then the question is, is it easier for me to write a better algorithm in C++ or in Python? And the answer will be, Well, for people who know C++, maybe they can do it in C++. It'll take them a lot of time. For people who don't know C++, it's not a question. And for people who know C++ and Python, maybe it'll be faster in Python. And getting a better algorithm will get you way more speedups than whatever percentage the language costs or buys. So that was mine, and I think you had thoughts about this.
I had thoughts about it because I thought it was an idiotic comparison. Many things we are dealing with today are just not suitable, and I would just even claim not just uncomfortable, but impossible to code in primitive languages like C or C++. We deal with too much complexity. We are barely surviving the complexity of the things we have to deal with, even when we can choose the languages we are going to use. Even when we have this choice, it is super hard. The industry doesn't have such a great track record at providing great software. And now we're being told, listen, why don't you use very primitive tools for the elusive idea of using less power? It's a choice. At the end of the day, who am I to say? But my guess is that if that's how things are going to go, there are tons of software that are just no longer possible. It's thinking that it's just a matter of choice and we are being sloppy and we are the equivalent of flying private jets because we use high-level languages is idiotic. It's absolutely idiotic. Besides, there is something that, if you want to talk about the comparison with, private jets, for instance, there's something that people forget is that, let's say that I have an application and this application happens to run, say, on servers, and it's poorly written and it's using 700 cores. I have a financial incentive to find a way to run it on fewer cores and reduce consumption because it's my money I'm actually going to be spending, or my employer's money. So in other words, the incentives are clear. There is the post itself is making an idiotic point just to be in sync with the current trend of saying, oh, languages can be environmental friendly. That's a joke. I mean, all things aside, I'm not saying that the question of power consumption is irrelevant, but it is irrelevant to the question of programming language, in my view. So
Yeah.
that's me ranting. I agree with that.
So recently I was working with folks who hated Java for whatever reason. I'm not a fan, I'm a neutral observer, and they wanted Rust. So you're building a system, and they don't like Java because garbage collection and slow and la la la. And if you think power in terms of power, maybe you can think, oh, garbage collection, it's going to be, power hungry perhaps. So you pick a language like Rust, which doesn't have a garbage collector. And first, you're spending quite a lot more time thinking about how to deal with, the type system, the borrow checker, because you have to make sure that, things get properly reclaimed. And then you start to get tired, and then you say, okay, fine, whenever I call into something, I'll just copy the whole data structure. At least nobody will bother me. So now you've done what? So you've got rid of garbage collection, and instead you've added whole lots of copies. And you think you won? Maybe, but it's not so clear, right? It's not so clear. And getting the algorithms to work well when you have to deal with all these issues of whether should I copy, should I use a reference counter? I mean, it's all slowing you down. So my point was, in the end, the system we built in Rust was fine, but I'm pretty sure the same system in a garbage collected language would have been done 3 months earlier, and would probably have worked even a bit better.
It's interesting that you say that because I don't dare make strong claims about Rust. The people who use it are so enthusiastic about it that I say, well, they may have a point from a distance. So I have no real or even superficial exposure to Rust as a programming language. My take is that there are applications where getting rid of the garbage collector is an absolute must. I really appreciate that. but claiming it as a dogma that should apply to everything is a little bit too broad as a concept. I'm not going to even say I'm lazy because I think I'm a rather hardworking person, but I'm a paranoid developer. I don't trust myself. I use all the help I can get, and the garbage collector is absolutely one of the things I could hardly live without. Perhaps I should try Rust. I could be convinced otherwise, but my gut's feeling don't go in this direction. But that's an interesting segue because I wanted to see what are your thoughts about the interviews? What came out of those series of interview we did that you did not expect?
It was interesting to see the path people took. So when I so this is going off technology a little bit and going just sort of how do people get into our field. And so I spoke with Martin Odersky, I spoke with Cliff Click, and it's interesting that there's it seems like there were two kinds of path: people who were like you, who started in computing from the very beginning, and then others who were more accidental, who ended up into it accidentally. And I was fascinated, hearing about the way people get into our field. And me being an accidental computer scientist, I'm always sympathetic and reassured to hear that I'm not the only one who just fell into the pot fairly late. Because I said, this was mostly a delaying tactic, and also what I didn't mention is my life dream was to be a movie director, right? So it was not even like the thing I thought I would be doing yet. I don't think I can do anything else today, but it was interesting. So that this is not a technical answer, but talking to these folks made me realize how many different ways we end up where we are, and there's so much random coincidences, right? It's just like these things that send you one way or another. And it's often what I try to tell to beginning students is that you can't predict where you'll end up. There's no way. And at least for computer science, I think all sub areas of computer science are interesting. We just happened to end up here, and I found these stories the most. What I like the most about the interviews, like how did I get to where I am? What was that path?
I really was amazed at some. There was one commonality that amazed me by how consistent it could be predicted was the level of passion. Each and every one of the people I talk to, even if they have sometimes the more subdued characters or they're shy, but there is something about, oh, listen, languages, compilers, and parsers, and lexers, and type systems, and more and more and more. So there was something about the passion that was really, really nice, I thought. That's what. Be the diversity. You got people that have from totally different kind of horizons, totally different takes. And it took me a while to adjust and let people talk, even if they told things that I would totally disagree with. But I've become, interview after interview, became more sympathetic to the different opinions. Hey, listen, it's not about me. It's about the interviewee. So that was the second part. And sometimes in a way that I thought was mind-boggling. The example that comes to mind is that I had that really great conversation with Walter Bright, the designer of the D programming language. Super nice guy and super approachable and crazy smart. There's no question about that. And then he said something that I thought was like the most amazing statement ever to make. So D is a language which is essentially inspired by C++, with trying to correct a number of flaws successfully. I have to say it's a very smart design. And there is this, and it supports an optional garbage collector. And then Walter says, well, the garbage collector allows you to do something quick and dirty. And then he went on and saying, obviously, if you do something serious, oh, you must do it without a garbage collector. He included the garbage collector against his own judgment. He included the garbage collector saying, I include it because, but I really don't think you should use it. I thought that was such an odd statement, while I would start with the exact opposite. When in doubt, garbage collect, and then we'll talk. So, and I respect his opinion and his experience, and he's smart, and I wouldn't dare say I'm right and he's wrong. But the difference in opinion admittedly, it's only a detail, but still, it's a remarkable difference of opinion. I thought that was pretty staggering.